This presentation will discuss the continuous variable transmission, starting with the definition. A continuous variable transmission (CVT) is a type of a car transmission that doesn't use traditional gears. Instead, it smoothly adjusts to give you power as you need it. So, unlike other transmission design, this type of automatic transmission use pulleys and steel bands instead of traditional fixed gears. The function. A CVT uses two pulleys connected by a belt. One pulley is linked to the engine and the other goes to the wheels. These pulleys change size to adjust power based on speed, which means the car doesn't have to shift like regular gears. Purpose of CVTs. CVTs make driving smoother and help save gas because the engine can stay at its best power level without jumping between gears, which it helps with the fuel efficiency and makes for a more comfortable ride.
History of a continuous variable transmission. Although CVT has recently gained popularity with new innovations offering greater efficiency, the design has existed for centuries. Leonardo da Vinci designed the first CVT transmission in 1490, although it was developed in 1886 by Daimler Lillard.
Damien Lillard.
Ano ba yan kasi? Ulit. Palis ka dyan. Bakit tayo? History of a continuous variable transmission. Although CVT has recently gained popularity with new innovations offering greater efficiency, the design has existed for centuries. Leonardo da Vinci designed the first CVT transmission in 1490, although it was developed in 1886 by Daimler and Benz, was not officially patented until now. The CVT first gained prominence in 1910 when Zenith Motorcycles produced a CVT model that was so efficient it was banned from hill climbing competitions. By the late 1980s, the CVT had entered the mainstream. Thanks to Subaru in modern times, almost every manufacturer has at least one model with a continuously variable transmission.
What's up guys? So today we're back and today we're going to discuss the parts and functions of a continuous variable transmission or known as CVT. The CVT consists of 10 parts. The first part is the input shaft. The input shaft transferring drive from the vehicle engine assuming engage through the clutch system into the gearbox. Front differential. The front differential is to support the steering and process the shock generated by the bumpy surface of the road to the left wheel. This wheel transmits the rotational force from the differential to the left wheel, allowing it to drive the vehicle forward. Chain. The chains connecting the input shaft to other components like pulleys or differential. Pulley set 2. The pulley set 2 works in tandem with other pulleys to control the transmission's gear ratios.
And the sixth part is hydraulic control unit valve body. Directs hydraulic fluid to engage different gears using solenoids. Oil pump. Oil pump circulates transmission fluid through the system providing lubrication, cooling, and hydraulic pressure necessary for gear shifts. Pulley set 1. It adjusts transmission gear ratios by altering the effective diameter. Planetary gear train. provides multiple gears ratios within a compact setup. Forward clutch. Forward clutch engages the forward gears, allowing the vehicle to move forward when power is transmitted from the engine to the wheels. And that's all the parts and function of CVT. Thank you.
I will be talking about the basic construction of a CVT or continuous variable transmission. A continuously variable transmission is a type of automatic transmission that provides an infinite number of gear ratios, offering smooth and efficient power delivery. Here are its basic components. Number 1. Primary pulley or drive pulley. This pulley is connected to the engine and varies its diameter based on the engine load and speed. 2. Secondary pulley or driven pulley. This pulley is connected to the wheels. It also changes its diameter to adjust the final drive ratio based on the engine power transmitted through the primary pulley. Number 3. Belt or chain. The belt, or sometimes a chain, connects the primary and secondary pulleys. It moves smoothly along the changing diameters of both pulleys, transferring power from the engine to the wheels. Number 4. Hydraulic system. In many CVTs, a hydraulic system adjusts the position of pulleys, enabling them to change their diameters. Overall, CVTs are widely used in various vehicles, especially to small to mid-size and hybrid models, where fuel efficiency and smoothness are prioritized. That's it. Thank you.
The most common type of CVT use a V-belt which run between two variable diameter pulleys. The pulleys consist of two cone-shaped halves that move together and apart. The V-belt run between these two halves, so the effective diameter of the pulley is dependent on the distance between the two halves of the pulley.
Toroidal CVTs. Toroidal CVTs are also known as traction drive CVTs. Use disc and roller instead of pulleys and belts. This design allows for higher torque capacity, making them suitable for the performance vehicle that requires more power.
Continuous Variable Transmission or CVT. The continuous variable transmission is an advanced type of automatic transmission that offers a seamless and efficient driving experience by allowing for an infinite number of gear ratio. Unlike traditional automatic transmission with a fixed gear set, a CVT continuously adjusts the gear ratio to optimize engine performance and fuel efficiency. This involved designs eliminates the distinct shift points found in conventional transmission, providing smoother acceleration and better responsiveness to varied driving conditions. A CVT operates using a system of a pulley and a belt or a chain. The primary component include two variable diameter pulley. One connects to the engine and the other to the wheels, and a flexible belt or chain that links them. As the vehicle accelerates, the diameter of the pulley changes, allowing the belt to move up and down the pulley surface. These shifts of the belt enables the CVT to adjust the gear ratio continuously, ensuring that the engine operates at its optimal RPM. For fuel efficiency and power, the CVT is often controlled by the Electronic Control Unit or ECU that monitors functions such as speed and throttle position to determine the best gear ratio for the current driving condition. In conclusion, the continuous variable transmission offers a unique and efficient alternative to traditional automatic transmissions by providing an infinite range of gear ratio. This design enhances fuel efficiency and delivers a smoother driving experience by eliminating the noticeable shifts between gears. As a vehicle increasingly adopts CVT technology, regular maintenance, including fluid change and inspection, is essential to ensure optimal performance for longevity of this advanced transmission system.
Our Our topic for now today is continuous variable transmission. Continuous variable transmission is a type of automatic transmission that allows seamless gear ratio change without fixed steps. For example, continuously variable gear ratios, no fixed steps or gears, and improve fuel efficiency. And how CVT works. First is use belts, pulleys, and hydraulic controls for optimized power delivery and fuel efficiency. And what is advantage? The advantage is smoother acceleration, better fuel economy, reduced emissions, compact design, and lower production costs. And what is disadvantage? The disadvantage is unusual sound, lack of driver engagement, limited towing capacity, and higher maintenance costs.
Good day everyone. Today's discussion is about continuously variable transmission or CVT. A CVT is an automatic transmission that doesn't use traditional gears to transfer power. Instead, it employs belts and chains. In a CVT system, the input shaft controls the shifting and transmit power smoothly to the output shaft, which generates movement on the speed and the gear ratio. In transmitting power, a CVT uses belt, with the V12 being a commonly used type that runs between two variable diameter pulleys. However, compared to belt, chains can be more efficient and have better torque capacity, allowing them to handle high horsepower engines more effectively. Additionally, they can adapt to smaller diameters.